What does it really mean for an AI to think? Today, we're diving deep into front-end engineering. Front-end engineering. The product surface is the product. The user interface is the product. Front-end engineering now spans state management, edge rendering, real-time synchronization, and adaptive design across device classes. Strategic decisions at this layer directly shape conversion, retention, and trust. Engineering the surface demands a system-level discipline, design tokens as version data, component contracts as typed APIs, deterministic state machines for flow, and embedded observability. The edge is the new compute surface latency is revenue. Every state transition is an engineered contract. The front end is no longer a downstream concern. It is the primary platform. But here's where it gets interesting: the fragmentation ceiling. The fragmentation ceiling designed to code pipelines fracture under real-world pressure, Figma components, and production UI diverge within days. Component libraries lack a shared contract, causing visual drift and duplicated effort. Micro frontends introduce deployment complexity without interface guarantees. Teams replicate identical logic across React, React Native, and web components, multiplying maintenance cost. Velocity stalls as the gap between design intent and engineering execution widens each cycle. Current tooling treats the front end as a set of pages, not as a composable system. The result is fragile, siloed interfaces that resist scale. So what's the real problem? Let's talk about the missing abstraction. The missing abstraction front-end engineering lacks a unified modeling layer that formally connects design tokens, component interfaces, and business logic. Design tokens are static values. They don't encode behavior, state, or semantic roles. Components are built imperatively with no type-safe contract between their interface and the rest of the system. Backend APIs expose data shaped for the server, forcing front-end engineers to manually bridge the semantic gap. Every integration becomes a bespoke, fragile handshake, unscalable, untestable, and the root cause of constant drift. Without a shared schema, complexity scales linearly while team capacity flatlines. This raises a critical question: declarative front-end architecture. Declarative front-end architecture, a C-single machine-readable schema, acts as the source of truth, bridging design tokens, typed component contracts, and state machine definitions. This schema generates framework-agnostic, type-safe UI components that enforce invariance at build time. The state machines model user flows declaratively, making all behavior deterministic and auditable. The UI becomes a system of composable, verified artifacts rather than handcrafted views. This is an operating model for the product surface analogous to infrastructure as code, where the schema compiles into live interfaces. Design and engineering now share a single enforceable contract. Now, let's zoom in on the front-end engineering system. The front-end engineering system layered architecture design token layer visual primitives as versioned data. Contract layer typed component interfaces, variants, slots, state orchestration layer deterministic state charts for user flows. Delivery layer edge rendering, performance budgets, observability. Each layer enforces a strict contract. The full stack is generated from a single schema: parallel workflows, automated quality gates, and deterministic output across surfaces. A change in any layer propagates automatically. Drift is eliminated by construction. The system compiles the product surface for web, mobile, and emerging platforms simultaneously. Here's something most people overlook: composable primitives. Composable primitive design tokens, color, typography, spacing, elevation consumed as typed data. Component contracts, interface specs with variants, states, and slots. State machines, visual executable models of user interaction flow. Edge functions, dynamic rendering, personalization, A/B testing at the edge. These primitives compose entire application surfaces, authored once, validated by the schema, and reused across platforms without duplication. Every primitive is testable, type-checked, and framework agnostic. Change a token, and every surface updates instantly. The UI becomes an assembly of verified building blocks, not a patchwork of pages. Think about this for a second. Designer to production pipeline. Designer to production pipeline design tokens and component specs exported from Figma as version-controlled artifacts. Compile schema engine generates typed contracts and component scaffolding. Define state machines visually authored and linked to contracts. Verify automated gates for contract conformance, accessibility, and performance budgets. Deploy edge-optimized bundles with instant rollback, previews, and monitoring. The pipeline eliminates manual translation. Design to code has zero drift. Every change is traceable, reversible, and contract verified. From Figma to Edge in minutes, not sprints. And this is where things get complex. Concrete impact. Concrete impact, 90% reduction in UI integration defects. Contracts catch mismatches at build time. Design and code sync automatically. No screenshot-driven QA. Onboarding from weeks to hours with schema-guided guardrails. Front-end releases decoupled from back-end cadence. Teams ship independently. Consistent, performant interfaces across web, iOS, Android, and beyond. Automated performance budgets and accessibility gates enforced at every commit. Quality becomes a systematic property. Velocity compounds while risk drops. But here's where it gets interesting: the front-end platform. The front-end platform contract schemas become training data for UI-specialized AI models that suggest and generate components from intent. Edge compute dynamically composes personalized interfaces in real time per user context. A single schema targets every surface web, mobile AR, TV without rewriting UI logic, personalization, experimentation, and feature flags are native primitives of the delivery layer. The product surface becomes programmable infrastructure, continuously optimized and self-healing. Front-end engineering evolves from implementation to composition. Teams configure behavior, the platform handles optimization. So what's the real problem? Let's talk about the new mandate. Front-end engineering redefined from pages to systems. From manual integration to schema-driven contracts. From fragile, duplicated UIs to composable, verified product surfaces. This is the operating model for the next decade of digital products. Organizations that adopt it set the standard for speed, quality, and innovation. The product surface is now infrastructure engineer it accordingly.